Multi-digit multiplication using number chips. This is the Valentine's Day version, and this is a digital lesson. So it starts with explaining to the students how to line up the numbers. So they line them up in the ones place, same way they do when they're adding or subtracting. Now, if one of the numbers has more digits than the other, that number is going to go up in the top row. Next slide shows them that we're going to start multiplying with this bottom row, the number in the ones place. And we multiply from right to left. So 3 times 3, 3 times 2, and then 3 times 5. And the next slide shows them, if they look at the numbers in blue, 3 times 3 is 9. They're going to place the 9 here. 3 times 2, and this is actually 3 times 20 you want to explain to the students, because the 2's in the tens place. So when you get our answer of 6, it will also be in the tens place for 60. So again, right to left, 3 times 2 is 6, then 3 times 5 is 15, and we get our answer of 1,569. Now students are going to start on slide 5, so every slide has all the numbers the students need. So this actually reduces frustration, because when these problems get more difficult and they see the numbers aren't working, they know they've made an error and they need to go back and look again. They know that they have to use every single number. So they move these number chips by clicking and holding on the edge. Click and hold, and then they can move it wherever they like. So from right to left, 2 times 1, 2 times 2, and 2 times 3. So it starts out with some simple problems. It gets more difficult as they go. And then 3 times 3, 3 times 2, and 3 times 7 is 21. Now every single problem on the slides is connected to a letter that's in a yellow heart. So they want to match this letter with their answer. If they do that, then on the final slide, they'll be able to solve a Valentine's Day riddle. So next slide, same thing. And then they're shown how to multiply when they get a 2-digit product. So here, if they multiply 4 times 7, they're going to get 28. Well, they leave the 8, and then the 2 gets moved to the next column to the left, right above this number. So then we multiply 4 times 4 is 16, and add that 2 gives us 18. The 8 stays there. The 1 is carried to the next column to the left above this number. So then it's 4 times 6 is 24, plus 1 is 25. So the answer, 2,588. Students are going to be doing that on the next few slides. So these smaller chips are going to be for the numbers they carry. So 5 times 2, they're going to leave the 0 here and carry a 1. 5 times 3 is 15, plus 1 is 16. They're going to place the 6, carry the 1. 5 times 1 is 5, plus 1 is 6. And then 5 times 7 is 35. And they get their product of 35,660. They're going to do the same thing on the next slide. And then they're shown what to do if they get a 3-digit by a 2-digit number. They're going to break this down into 2 different multiplications. So the first row here, they're going to multiply 312 times 3. And they'll get their answer here. And then 312 times 20. They'll get both of these products. They're going to add them together to get the final answer. So students are going to be doing that on the next slide. And they'll get a little bit more practice. And again, each product is going to be matched to a letter in a yellow heart. Then they've got a 4-digit by 3-digit. So here, the zeros are already added to the third row. So they're going to break this into 3 parts. 2,734 times 6 in the first row. Then they're multiplying by 40, so they have to add a 0 before they start going from right to left. And then when they multiply times 300, they have to start this row with 2 zeros. And then they're going to add those products together. Same thing on the next slide. And then when they get to the final slide, they have a Valentine's Day riddle. And they're going to go back to the previous slides and find all of these products. and they're just going to type in the letter in the yellow heart that matches, and they should be able to solve the Valentine's Day riddle. So this is a Valentine's Day lesson on multi-digit multiplication with number chips.